Morning, boss.
How you going?
Good, thank you, good.
Great.
Oh.
Can I help you?
Yes, thanks. I'm after a little something for a new friend I'm meeting tonight.
Lovely. Well, look, Oscar here will help you. It's his first day, but he's very experienced and qualified. He's actually studying for a PhD in botany at the university.
Oh, wonderful, wonderful.
So, what were you after?
Well, she's pretty classy, a bit sort of out there, maybe something like those gerberas, nice and bright.
No. I have just the thing.
And that is?
It's kangaroo grass. Femida australis.
Grass.
Yeah.
I need to make a good impression.
Oh, they will. They're native, you know. Endemic to this area.
Endemic, right.
Yeah, forget those exotics. She'll want something grown right here in Canberra. Oh, like this. Casuarina cunninghamiana.
Pine needles? That'll really blow her away.
Oh, good. Shall I wrap them?
No. It's a date, you understand. Have you ever been on one? I can't just turn up with a handful of sticks.
Sticks come from plants.
So do flowers. Could we direct our thoughts that way?
Oh, these are flowering.
I'm really hoping this won't be my last date with her.
Non-flowering plants are beautiful too.
I wonder if there's an actual florist nearby here.
I know. How about the chocolate daisy, Arthropodium strictum?
Chocolates, that's a good idea.
They actually smell like chocolate.
Oh, really?
Oh, you have to use a little bit of imagination, but they're very pretty. Oh, the Yas daisy, Amobium craspedioides.
Yas has a daisy? No way.
Yeah.
Right? Yeah, let's have a look.
Oh, no. We don't have any.
What?
Well, don't be stupid. It's early winter. They don't blossom until mid to late spring.
So well, what about the chocolatey ones?
Early summer.
Can't I just have the gerberas?
I wouldn't. They're from tropical areas. They're not even Australian.
Well, roses then? I mean, it's only a first date. I don't want to, freak her out.
Do you have any idea how much fertilizer they consume? Huge carbon footprint.
Fake flowers?
We've taken a plastic-free oath.
Okay, those ones over there?
Where? Oh, you mean the Welwishia Ganinator farm?
Oh, do you mean the gymnosperm?
Over the back behind those ones.
Oh, this bit.
Thanks for nothing, nerds!
Please make welcome our first guest scientist from the ANU, Brittany Brockett!
Britt, good luck tonight. See you afterwards.
Exotics?
Oh!
Hi everyone, I'm Brittany, and as mentioned, I'm a PhD scholar over at the ANU, and I'm working on incorporating genetic information into threatened species management. And every day when I talk about my research, I tiptoe along this strange line of sounding like a very cool, fancy, interesting researcher and kind of being over the top because I forget that not everyone is invested in my research as I am. And it's never more obvious than when I talk about some of my favourite facts because I'm someone who has favourite facts, which puts me probably firmly on the over the top side. Because not everyone seems to understand that my favourite facts are some of the most interesting things. Did you know that carcinization is the tendency for things to evolve into crabs? Not your housemates becoming crabby, because you forgot to take out the bins. But crustaceans become more crab-like over time because crabs are apparently the peak of crustacean evolution. And then, furthermore, did you know that no one knows how freshwater eels reproduce? Because they are eerily secretive about it. And one last fun fact. Toucans, 50% beak by weight, which just blows my mind. And none of these things have anything to do with my research, of course, but they're all examples of really interesting facts that can be hard to make people see as interesting. But there was some communication wizardry that helped me remember that lobsters get crabby about more than the bin sometimes. And I think that that's some kind of zhuzh that could really help me sell conservation genetics. And I say that conservation genetics needs this zhuzh because when I start talking about the fact that we need to be managing our threatened species to make sure they don't become as inbred as the English monarchy or any other monarchy for that matter, people start to get these strange looks on their face, and those strange looks kind of morph into panic as I start talking about needing to combine the genetics in our reintroductions to make sure our populations are adaptable for future changing environments. Because when I start talking about combining and genes, I can just hear the Jurassic Park theme song like emanating from people's heads. And it isn't helped by matters that I also start talking about things like quoll jelly beans and New Holland nugget mice, because they're my study species and people get worried I'm talking about eating them, and the looks on people's faces turn into like, are you sure the institution you're from is a university? But I think the zhuzh that helped me remember all about carcanization and toucan bills can help me convey to even the most reluctant recipient of my ecological enthusiasm that conservation genetics is at least as cool as eel sex. To do that, I want to communicate my research. I want to share my science through memes. You might think that sounds a little bit crazy, but memes are cultural phenomenon by definition. A meme is something that goes through everyone and we all know and understand what it means. There are really common examples of this, like if I knocked on a door, we all know that is finished, right? And then for all the native-born Australians in the audience, there is one phone number we definitely all know, and that would be for the reading and writing hotline. 1300 65506. Yeah, thank you, this half of the room. So memes, and it's an academic's dream for my research to become as well known as a TV commercial like that. And actually, bonus fun fact, memes as a word were actually coined by Richard Dawkins in his book, The Selfish Gene, which means they were made for genetics, right? It's good for me. So to do this, I want to go back to the place that helped me learn all about memes in the first place. And as a serious researcher who's supposed to spend all her time sitting down in the library, but actually spends a lot of time scrolling through the internet, that would be the internet. There's just a cornucopia of blank picture templates sitting there waiting for me to harness them for the good of science. And I've had a go at that. So bear with me because I have tried to communicate conservation genetics. Right. So, as I have already been talking about, my research is based in conservation genetics for reintroductions. What are reintroductions, you might ask? Well, sometimes a species go extinct in an area for one reason or another, and rather than being as dumb as Robin and accepting that the species is gone, we can actually take individuals from other places and bring them back to where they've been extinct and restore ecological processes. Thank you. And this is really important because reintroductions are also an insurance policy for that species' survival. And hopefully they've remembered to get flood and fire and bad genetic management included in that insurance policy. Because I think conservation genetics as a discipline started something like this. Without conservation and without genetics in conservation, it's kind of a fire that we all just try and ignore. And you might be wondering how, for reintroductions, conservation genetics is important. And the most obvious example of that would be that inbreeding is bad. We all know this. We've known this since Darwin's time. He did marry his cousin, but we're still going to take him at his word. But actually, genetic similarity as an issue for reintroductions is more than just marrying your cousin. Charles, it was a bad idea. Genetic similarity can actually be when you take a lot of individuals from one place and don't capture the whole diversity, because then you're missing all these chances for that population to have diversity that helps them adapt into the future. And that's a mistake, because we're pretty much chucking a stick in the bike spokes of a reintroduction. And you might start rolling around on the ground wondering why your reintroduction isn't successful. And buddy, you put a stick in your bike spokes. Like, we need to consider genetics in order for a population to be able to adapt into the future. So my point, which I've hopefully made by now, is that a successful reintroduction is the same thing as a reintroduction that considers inbreeding, genetic diversity, adaptive potential as really important facets of that reintroduction, because a successful reintroduction is a reintroduction that considers genetics. And thank you, Pam. They are the same picture. And on that point, even Drake can tell us that we need to plan our reintroductions and our monitoring schemes right from day one, because it's a missed opportunity if we only start thinking about things 10 years down the track and have no idea what's happened in the meantime. And look, I know I've rambled on a little bit about conservation genetics, but hopefully I've made my point. And I think that this is a stupendous way for us to start communicating our research and make conservation genetics cool, because it's going to reach a section of the population that doesn't want to sit around and listen to me ramble on and on about just how interesting it is that genetics is the one thing that we can't exclude from our reintroduction plans. And I'm going on again. Forgive me. But look, you have sat and listened to me ramble for long enough. Thank you, everyone. It has been a memorable night.